Well, thank you everyone for attending today's webinar, The Blind Man and the Elephant, Reducing Risk with Hadoop Visibility. My name is Christina Lamb from 451 Research, and I'll be your moderator today. Presenting on today's webinar first will be Eric Hanselman, Chief Analyst at 451 Research. Following Eric will be Jim Waring, Advisory Software Consultant at BMC. Just a few housekeeping items before we begin. To ask a question, click on the question button, and we'll get to as many questions as possible. If not, we'll respond to your questions later. A copy of the slides will be made available to all attendees after the webinar. And lastly, please don't forget to leave feedback at the end of the webinar. We really appreciate it. And with that, let's get started. Eric, take it away.
Thanks, Christina. Move us forward here. So in terms of looking at new technology, I think it's useful to look back on what's an old story. The idea that understanding and assessing its importance and its impact can be really difficult. If we think about the story of the blind man and the elephant, you've got a set of folks who are trying to figure out a particular problem. They've got an issue that they're trying to understand and really looking to identify, what is this thing? And if you have a limited view of any particular situation, it leads to the potential for either limited understanding or potentially misunderstanding of what that really is and where it fits. And I think it's a particularly apt analogy to use with what is becoming one of the hottest analytic technologies that are out there, Hadoop systems. The challenge with any complex system is that the details can be hard to discern, and especially in new technologies that are hitting the market, because there's a limited understanding of the technology, its impacts, and really what a lot of the operational expectations are around it. That can be doubly so. So we start thinking about moving towards Hadoop capabilities. What we're going to be talking about today is the fact that it's important to understand a whole range of different aspects of that environment. And especially as you start assessing the way in which you're going to both deploy and run it over time, you need to be able to have a view that's going to give you the depth and breadth of understanding of both what the environment itself and what the cluster capabilities are and how that's really running, and what the experience of your end users are going to be. It's a situation, especially with a lot of big data analytics, expectations for performance and capabilities and, more importantly, results can often be out of whack with reality. So understanding what your capabilities are and what you can deliver and being clear with the end consumers of those technologies can help to make sure that you prevent misunderstanding and that you meet the expectations, however lofty they may be, for the kind of capabilities that you're trying to deliver. So one of the challenges with Hadoop environments is that, as with anything that's been getting a lot of press, and we might even say hype, is that there's I think most organizations in some form or fashion are looking at what its capabilities are and how they can be applied to their particular business. But it presents some difficulties because of the fact there's a limited knowledge about what the real capabilities are, but a lot of aspirations for what they'd like it to be. Of course, there's that expectation that you simply push as much data as possible into your cluster, you wrangle the appropriate capabilities around it, fire off a few jobs, and then you start to have insightful answers about everything that you might want to know. And that leads to a focus on being able to get to those final results without really thinking about what the operational pieces are that have to get you there. Hadoop can be tremendously useful, but the operational aspects are complicated. And with any major information technology project, it's something that you've got to have a solid understanding, both getting into what you're trying to actually deliver and operating it as you start going forward. So it's an area that has lots of enthusiasm, and I wouldn't be a good analyst without giving you some market numbers for where this is growing and exactly how fast this is taking off. When you see numbers with compound annual growth of nearing 40% and markets that are soaring like this, it's a very strong indicator, confirmation even, of exactly how much enthusiasm is out there. And that's a marvelous thing in terms of identifying where all of that impetus and initiative is headed. But it also means that there may be a lot of budget pushed towards these environments that may be being driven there in ways that have loftier expectations than the environments themselves may be able to deliver on. And it's what makes sizing Hadoop environments so complicated. It's a matter, as with any project, you've got to be able to match what you're trying to put together and build with what the demands are going to be on that system. But because we're with Hadoop environments, we may not really have a solid understanding about what those capabilities are. There can be the potential for mismatch. Now, Hadoop environments can require significant amounts of resources, a lot of storage, lots of capability around the I/O of that storage and the computational capabilities of the cluster that you're building out. The difficulty in being able to estimate what the appropriate sizing is and how you run that can be challenged because running Hadoop jobs can take significant amounts of time, given all those resource requirements and such. And that time delay winds up being visible. It winds up being something that the amount of time the jobs take to run, how many jobs you're able to handle, what that overall queue looks like in terms of getting jobs put together, often is at odds with the expectations. You simply dump things into Hadoop and run them. The thought is that it's easy to do, and the delivery of those results is fast and simple. But of course, anytime you're trying to look at significantly large problems, the resource requirements for which are going to be significant, it's important to be able to balance both what you're investing to be able to build out the supporting infrastructure with the demands on the system that you happen to be running. Natively, Hadoop systems have got all sorts of great capabilities, but relatively limited management that's built into the Hadoop environment itself. And in terms of sort of those operational characteristics, there's also limited monitoring. And that means that when you're looking at how you're going to be deploying that overall environment and taking a look at how you're going to operate and run it, there can be challenges in ensuring and determining what the nature of any potential problems are and predicting what that performance is going to be. Because there are so many aspirational views of what the Hadoop cluster should deliver, it's important to also be able to set expectations. If you've got significant job densities, if you've got particular sizing issues around the jobs themselves, these are things that understanding them up front and communicating those back to the end consumers of the application can really help to smooth out any potential wrinkles in expectations for what it's able to do. So in thinking about deployment, there are particular challenges with any new technology in terms of understanding how you actually get that initial deployment put together, what you expect it to do, how you size it, really what you're going to spend on how it starts being put together. And with Hadoop, that's definitely the case. One of the challenges in analytics environments and potentially in this sort of problem is we're looking at solving a set of problems with a new technology and new approaches, is being able to estimate what that job load is going to be. It can sometimes be a difficult problem to solve. You may have particular understandings of what's that total volume of data that you're looking towards. You may have reasonable understandings of what the kinds of work you want to do, what the jobs are you're actually going to be firing up with that environment are going to look like. But when you start getting to expectations about how fast do you want that to execute, how rapidly do you need to get results, of course, situations like this, the answer can often be, well, we need it right away, and what that right away happens to be is a fairly abstract definition for what's the acceptable levels of performance in terms of how this all gets put together. So understanding that the job requirements certainly is something that's necessary up front. You need to start looking at really what those capabilities are that you want to be able to deliver. But you need to approach this with an understanding that that's something that has the potential to change very rapidly. There may be environments in which if you get data sets that are sufficiently constrained, you may know reasonably well what you're going to approach. But one of the things that we find with our clients is that more often than not, while there are good expectations for what they want to be able to do, those shift fairly rapidly as you actually get into the process of both running the analytic process and really starting to deliver results. Most of these environments start out in a relatively experimental phase that then evolves fairly rapidly as an understanding of what that environment can do for you starts to build. So thinking about these environments, just in terms of general clustering, just to give you some familiarity with the overall capabilities around this, fundamentally, you need to determine cluster size, exactly how many nodes you're going to be building out, and then the capacity of the nodes in that environment. In each of those environments, one of these key drivers is primarily the kind of storage that you're going to require to be able to build that out. The nice thing, useful thing about Hadoop clusters is that it's reasonably simple to be able to add additional nodes, to add capacity. But it's important to consider how you actually size the individual nodes as well. How much capacity and storage capacity you're going to deliver in each individual node. What kind of I/O density do you need? We're in an age where we're in a transition between spinning and solid-state storage devices, and some of those questions around I/O may drive some decisions around moving towards a preference for solid-state in some of this. Again, we're probably about a year or two out from any level of reasonable cost parity, but those are things that, especially in terms of building out those environments, you should start to consider. There is the ability to use compression within Hadoop environments. That is also somewhat of a double-edged sword. You want to make sure that you've got the ability to be able to get reasonable computational work done, and whether or not the benefits of compression in terms of effective storage increases are worth some of the complexities that potentially it introduces in those environments. The compute side is a little simpler. You're looking at core counts. You're looking at memory capacity. Memory, of course, is always one of those issues of more is better. But again, managing cost in those environments can drive some of those decisions. But keep in mind that these are things that you'll make initial estimates, and you'll want to relatively rapidly start to manage and monitor how well that environment is performing as you look for whatever that long-term growth happens to be for building out the cluster and whatever eventual capabilities you need. And that node sizing has specific impacts on a lot of those day two operations. Sizing, of course, is relatively complex as you just sort of step into this, but understanding how that environment is actually operating can be even more so. It is, as the graphic illustrates, a little bit like the Tetris problem of fitting jobs into the capacity of the collection of nodes that you have, because the individual node capacity has a direct bearing on what jobs can actually run on those individual nodes, how many jobs you can actually fit, and where those are going. And as you get these clusters up and running, you need to understand what's actually running on them, how are these jobs being fired up, what's actually utilizing the infrastructure, whether or not, in fact, you've got jobs that are running, being requeued, restarted, that may not have a direct bearing or may have gotten into a state where their original owners sort of moved on. The idea of zombie instances that may live on far longer in their usefulness is a critical issue where you've got concerns around resource consumption. There are also monitoring and management issues depending upon the particular distributions of the Hadoop distro that you're actually working with, because there are some differences in terms of how they operate. It's something where, from an operational perspective, as Hadoop infrastructure grows within an organization, if that happens to have been initiated from different teams within an organization, they may have started on different distros. And that's a point at which you need to understand what the management differences are and normalize some of that operational piece so that you can actually manage it. It's important to make sure that in terms of your administrative team, that they have the necessary tools to be able to work through a lot of these kind of capabilities. Those day two pieces are primarily ones of ensuring that you've got solid utilization, you're optimizing what you have, and that you can understand what those trends are that are moving forward. One of the hazards of success, if you're working it well, if the cluster is working in good shape, you can expect that utilization to grow. People are getting good results. Hopefully you've invested wisely. You're using your infrastructure well. But that means that you need to understand where you make next steps and how you grow. One of the things that's most useful in understanding that trending is taking a look at the job types and characteristics that you've been running and watch those trends. Because what we've seen is that there is a definite evolution of an understanding of what can be run, how it's running, what the demands are for those sort of capabilities. And you need to keep an eye on what is going to be an ongoing shift in that workload type and its utilization levels. And that can help you guide what are the next steps in expanding those environments. These are tools this is information that you'd use to be able to understand how you're going to add nodes, what kind of characteristics, what types of nodes you're going to add as you start to move these forward. Now, in many cases, our experience with our clients has been that they may have started out experimenting in cloud. They may have started out experimenting on-prem, but it's something where longer term, there's generally a look to cloud. And in some cases, this can be something of a boomerang of starting out with cloud just as an experimental piece, running clusters there that are easy to spin up and take down. You don't have a physical commitment. But as you start to grow in larger scale, on-premises capabilities, physical deployments can certainly give you substantially greater performance. But then in terms of being able to handle spot on-demand requirements, having the ability to then extend back out the cloud in a production environment can also be particularly useful. So when you're thinking about what that journey is for what your Hadoop infrastructure is going to look like, it's important to keep an eye on what those longer-term capabilities are, and understand that this isn't an all or nothing in terms of how you look at cluster deployment. If you were looking at being able to manage across both on-premise and cloud capabilities, that's a path in which you need to be doubly careful about how you're setting up and managing this. What you want to be able to get to is something where you can reasonably seamlessly manage both your cloudy assets as well as your directly controlled assets in terms of understanding what those resources are and taking a look at how you're going to do job placement across those environments. That can present some significant challenges, just simply because of the fact that you're operating in what are two different environments, but that still may have enough differences to make those operational pieces something a bit more of a challenge. I know I've put a whole bunch of sort of cautions up here in terms of it, but it is possible to run Hadoop environments very effectively. We've just come through the 10th anniversary of Hadoop, and it's a tremendously useful tool. There are all sorts of capabilities that you can deliver to your organizations with the analytical capabilities that Hadoop can provide. It's something where some planning, some homework is really necessary to be able to make sure that you've got a Hadoop infrastructure that is performing to the needs of your end user communities, but not breaking the budget in the process. Because it is a relatively resource-intensive application, it's something where you want to make sure that you've got the ability to understand how those clusters are operating and to make sure that you can grow and manage it. One of the cautionary pieces around this is that as demand grows, as you're becoming more successful in terms of delivering value, in terms of that capability, it starts to create more operational challenges. But as long as you can track them, if you keep on top of it, manage it effectively, it is capable. It's not rocket science, but it does require work and visibility and an understanding, really, of what those capabilities are and how you can leverage them. All right, and with that, I want to hand it off to Jim.
Thank you, Eric. What we are going to step through now is a brief overview of BMC's capacity optimization for big data. And what we see our customers asking for, typically from a use case perspective, kind of falls into these four areas. First of all, we're being asked, what's the impact if we start removing some nodes from a big data cluster? What's going to be the impact on the business application and our ability to run the required jobs to support those business applications? The second use case is really sort of understanding the risk within the environment. It's already been provisioned. There's a certain run rate in terms of its level of usage, and what happens if we apply growth to that environment? If the trends continue in terms of data ingestion and the running of the jobs, at what point are we going to hit some bottleneck or some pinch point within the environment, and what bottleneck resource is that going to be? The third area is really sort of is getting your arms around the whole of the big data environment. You could have many distributions of Hadoop, a mix of Hortonworks and Cloudera. They could be split across different technologies. They could be split across different environments in terms of production, pre-production, and so on. And without something like capacity optimization, you don't get a single point of reference that can normalize all of this data and address the questions in terms of, for a whole enterprise, what's been the growth rate across all of these environments, how much, and quantify how much is going into those different areas. And that leads into the last typical use case in terms of the business wanting to know where's the money going in terms of the infrastructure that's supporting Hadoop. How do I break that into some meaningful chunks and understand this is how much is going off into the cloud, and this is how much is on-prem, and so on and so forth. The people that are asking these questions fall into typically three different groups or personas. And we're looking at the people that are looking primarily at the financial implication as a business owner and answering or wanting to see the visibility of cost within the environment. The next area down is from an operational perspective and understanding the potential bottlenecks within the environment, being able to look at the available headroom to innovate and meet business demand in an agile way. And then the last area is looking at it from an architectural and a demand management viewpoint in terms of we know that there are going to be mergers, acquisitions, or new applications that are going to be hitting the big data environment. What's the impact of that actually rolling out, so that we can optimize the environment, get the right size, don't over provision or under provision those environments, and then moving on from there. So to be able to address those use cases to those particular individuals within the organization, there's some required capabilities in terms of how we pull all of this data together. Now, what I'm going to step through here is an architectural overview of what capacity optimization is. So at the bottom, we have lots and lots of different data sources. And it's not only just looking at the big data that's coming through, but we can also look at business and application metrics that are associated with that. We can look at storage-centric data, compute, and so on. We look at making the most of the incumbent performance monitoring, performance management solutions within all of those different technologies. Rather than coming up with our own proprietary agent that sits across all of these different areas, organizations have already made a large investment in terms of the tooling that they have in place. And the capacity optimization is not really about the generation of data. There's lots and lots of data that's already out there. It's understanding the patterns, the relationships, the profiles within those data sources, but then also in context of the business that they are supporting, and also in context of the other data sources that are associated with delivering that capability. So we have a series of connectors, or what we refer to as ETLs, extract, transform, and load, that can communicate with these data sources and then load them into capacity optimization into a single capacity planning database. And what we're giving you is a management information system that is hooking into the resource consumption across IT, what that means to the business, and so on. That can be augmented and enriched with information from a CMDB. So this is where our service models, service context, and additional attributes can come from. We can also hook into what's happening in the future in terms of demand management, projects that are coming over the horizon, and understanding what the resource profile is of those new projects. We can also hook into the operational management point of view and look at doing proactive notification so that when we detect a potential saturation point, we can raise that flag so that someone can action that and resolve that resource constraint before it compromises the service to the business. All of this is under role-based access control. So from a big data point of view, we can be very specific in terms of what we present to the individual stakeholders, be they the Hadoop administrator, the architect, the business owner, or the enterprise capacity planner. We can give them the views, the segregated views that are, and reports that are pertinent to what they want to be able to achieve. But today, what we're going to do is get the spotlight onto big data. And what we have in terms of this zero impact data acquisition is 2 certified methods of getting data from both Cloudera and also from Hadoop. What this means is that there's no agent technology that has to be deployed on the nodes or the clusters. We will hook into the management layer, and you can see here that we can do this for Cloudera. It's certified by them as well, and the data that we can harvest from the Cloudera manager is consolidated and analyzed and then published through capacity optimization to those different stakeholders at the top. We can do exactly the same thing for Hortonworks. The certification there is into the Ambara layer to take that data out. What this enables us to do is to have some predefined out-the-box dashboards that will be populated as soon as you plumb the environment in. So there's a very quick return on investment in terms of plumbing the solution in and then getting this kind of level of dashboarding or views coming out of the back end of the solution. In essence, what we are doing here is giving you the mechanism to have a single pane of glass for the whole of your big data environment that consolidates the information from your different distributions of Hortonworks and Cloudera across multiple environments, so that you can then see that headroom run rate and the trend across CPU and memory, and then understand what the trends are and potential saturation points. You know, how many days have I got until I'll hit a limit? It could be 30 days, 60 days, 90 days, and we can articulate that in this view. We not only do the aggregation, but we enable you to then drill into the detail as well. Here, the next level down, we can look at the major components of the Hadoop environment. At this level, we are looking at the Hadoop file system and doing exactly the same thing that we were doing on CPU and memory. What has been the past performance? What have been the trends in that? And where do we see the saturation points in the future occurring within these environments? We can do this for the Hadoop file system, but we can also do it for the overall clusters and individual clusters, and be able to look at a cluster and then all of the nodes that constitute that cluster. Are there, you know, as a whole, a bottleneck that we need to be aware of, or are there some individual nodes within the cluster that could be burning hot either now or in the future? With this analysis that you can see here, what we are able to do is look at any metric. We've just picked on the Hadoop file system here, but we could be looking at the number of jobs that are run within a certain resource pool. We could be looking at CPU, memory, I/O, network, any metric. And we can look at a trend within that and then extrapolate that forward to understand what the residual capacity within the environment is. In terms of, in this example, we're just doing a straightforward linear regression with some bounds of confidence around that line of regression. The top line is giving us a pessimistic forecast. So we're saying here, this is the earliest point at which we think we could run out. The bottom line is giving us a pessimistic forecast. So that's, you know, the furthest point at which you would be comfortable with running at. And then the line in between those two is your average or your mean forecast, which is saying all things being equal, we'll probably get by until this point. But it's a very quick and easy way of understanding worst case and best case scenario in terms of the impact of that particular trend. All of that can be encapsulated into a scheduled report. So we can do these scheduled reports on exception as well. You may have thousands of nodes, but this methodology enables you to look at maybe the 5 or 6 nodes that are going to have a memory or a CPU or a file system issue, and they are the only charts that will appear within the report, rather than having to wade through thousands of charts just to find the needle in the haystack. We can do that. These reports could either be generated on a schedule, so you'd get the monthly exception report, or we can also have a filter on there to say, if there are no red flags, if there are no exceptions, then you don't get a report. Everything's hunky-dory. The next example I'm going to give is the fact is a showback or a chargeback view, which is very useful from a business perspective. And what we can illustrate here is that horizontally across this matrix, I've got the individual departments or lines of business that are consuming resource within Hadoop. And then we can break out their resource consumption by these billable units. Now, the billable units can reflect your on-premise capabilities and your cloud capabilities, physical environments and virtual environments. That then gives you a mechanism to understand, well, this is the cost of my AWS big data or my Azure big data resource consumption, and in context make a comparison of, well, this is how much it's costing me on-prem as a proportion of the total bill. So here we can see we've delivered a pie chart for that, but then we can see the run rate of how those resources are being consumed across a time period. It could be a month, could be a quarter, could be a year, in terms of how those resources have been consumed, giving you a lot of visibility and control over how you then sort of utilize your environments and look at how you encourage maybe the adoption of cloud or looking at it in context of those on-prem situations. Again, this report can be scheduled and run on a regular basis, minimizing the manual intervention that needs to be done to do this without such a solution as capacity optimization. Drilling into more detail here, we can look at the configuration of each of the clusters and the resources within that, giving you, again, total visibility of how the environment is being consumed in order to support the business. And then, again, this is, again, more detail at the cluster level from a Hadoop file system piece. And then we can also start looking at the jobs. Yarn is the job scheduler there. And now we can start seeing the utilization of the jobs, not only in terms of the resources that they consume, but also the elapsed time that they are experiencing. So it's almost as if you can take the job and translate or equate that to a transaction. We know what the transaction volume rate is, and the elapsed time gives us a view in terms of the response time for that transaction. We can use those as yardsticks to determine whether things are improving or degrading and by how much. And we can use it to model the environment to show, here's how many more jobs you can run before your elapsed times start to elongate as well. More detailed views in terms of the resource pools. So the resource pools are a mechanism where we can get like jobs to run within a guaranteed minimum set of resources. It also gives us a mechanism to do that linkage between a resource pool, the application, and the line of business that are generating those jobs. So here we're looking at the clusters and kind of wrapping it back to our kind of use cases in terms of, let's look at all of the resources and the services. We can do that from a cluster pool perspective and the topology of those environments. We can look at all of the key resources within that in terms of disk, CPU, and network and I/O. And we can relate that back to the Hadoop components in terms of the Hadoop file system, the raw file system, the MapReduce, Yarn, HBase, and so on. And then look at that from the infrastructure point of view, how we relate that to services with those modules that are mapped in there. And then in terms of the show back and charge back, look at how much those resources are actually costing the lines of business. So here, relating back to our personas who want to look at these environments, the value that they can get from this, from a business owner, they can see the visibility of costs, where those costs are being consumed, and use them to improve application performance and cost management around those applications. Typically, we see from an infrastructure administration point of view, you can start utilizing more and more of the white space and avoiding hardware acquisitions, making the most of the existing hardware. And that also has impacts on the cost of software as well. Typically, we're seeing up to 30% reduction in realized savings across infrastructure costing through having this disciplined approach and having a data-driven decision-making process, which leads into how the architects and how demand management is being delivered within that environment so that you get the right resources at the right time, neither over-provisioning nor under-provisioning, which means that you optimize your procurement processes around being able to roll up and have better planned acquisitions of additional capability. So with that, I'd like to hand over to Christina, and thank you.
So let's move on to our Q&A period. If you have a question, click on the question button to submit it. Our first question, what is the most common problem with Hadoop deployment? Eric, would you like to take the lead on this one?
Oh, sure. Well, I split it between both Jim and myself, but from our expectations and our conversations with clients, it's hard to identify any one common problem. I think the whole issue winds up being one of really a much broader set of challenges and understanding where you are in posture. They're both problems that you can potentially get into in terms of initial sizing, but those are things that you can work around with sufficient visibility. And it's mostly a matter of having an expectation that this is going to be a pretty dynamic environment. And I guess if there's one common problem, it's that things keep changing. I don't know, Jim, if you've got thoughts on the other side of that. It's but certainly just maintaining awareness, if nothing else, I guess maybe is what we could identify as a common problem.
Yeah, I think a lot of it is also around aggregated holistic view where we're pulling in all of them, and then because each customer is pretty unique in terms of their profile of use. So it's being able to do that analysis and there's different scenarios out to say, well, here are consequences of increased level of job activity in this area cause a potential in these particular results. Until you do the analysis, you can't actually preempt where those bottlenecks are going to.
Yeah, and actually you make a good point also about sort of the inorganic growth issue, in that you get different distros, you get Hadoop builds that are coming from different groups, and so being able to manage that effectively, doing a single pane of glass and avoiding a lot of the pain of the multi-management, that's certainly an issue that we see often. But again, it's one of those challenges. It's everybody wants a Hadoop cluster, so you get a lot of user-initiated deployments too. So yeah, being able to manage a lot of different environments can be a challenge in that front too.
Our next question, can TrueSight tell me the idle data that is occupying the storage and never used? I think this is probably one for Jim.
Yeah, I think from the views and the data that I've seen so far gathered, we don't get that visibility. Now, that said, if the data is there, or a monitor that can report that, and we can interface into that and accumulate that information in. So this kind of harks back to the architectural overview. There's a very open. I mean, it's almost a bit like big data itself. There is an ETL structure where we can take additional data into our management information system and then start being able to do all of the analytics and the reporting and the dashboarding information. So if it's there for us to harvest, we can get it and pull it into the environment.
The next wonderful question that came in is, Big data is unpredictable by its very nature. Can TrueSight forecast these peaks and valleys in the data?
So in terms of unpredictability, I suppose there's a few ways of answering. We could look at the past performance and the profiles and see what the peaks and the troughs have been historically. We also have the ability to put in some behavior predicted business analysis to say we anticipate these things are coming through the pipeline. Let's overlay those in terms of the organic growth and see what happens. The other thing that we can do is give you worst case scenarios, so that you can make a judgment about how risk averse you are to be able to cope with the unpredictability. Yeah. But yeah,
the what ifs are particularly important, and that's something in order to make those effective. Making sure that you've got solid communications with your user communities so that you can try out these scenarios and do those what-if analyses. And that's a matter of making sure that you're working with your cluster users, you have an understanding of what's happening, and staying plugged in to what that use is and what those expectations are. It will help to give you some visibility so that you can take advantage of the capability Jim was talking about to do that what if, because that's we're coming up to end of quarter, we've got a major new campaign coming out, those sorts of things. If you can stay plugged into your user communities and understand sort of what's coming on that horizon, that can help you to do it. I mean, this isn't, we don't have a crystal ball in any form or fashion, but we do have, there are predictive tools that are available to be able to do pieces of that that can help you understand what those impacts are. And as Jim said, that's that point that you can really start to do what are your tolerances in terms of performance. Make sure you can do that sort of worst case analysis and understand what the impact is going to be.
Wonderful. One more question. How much do I have to know about job mix to size a cluster?
Sorry, Eric.
Jim, you go ahead. After you.
Thank you. So you can take as a starting point a broad brush analysis to say all of the jobs, and then over a period of time, look at what's the correlation between these jobs running and the resources in the cluster being consumed. And we can do that, and you'll get a correlation table that says, these jobs have a 80% correlation with memory consumption and 90% correlation with CPU consumption, and so on. Your starter for 10 is to do that analysis, and then you can size things on a broad basis. What level is understanding how have you explored pools that can compartmentalize the jobs, so rather than just of all of the jobs that are running, use the resource pools to split them out into more meaningful job types, and then we can do technically what's called multivariate regressional analysis. I've got 4 different types of jobs that are going on simultaneously. If I look at the statistical linkage between that and the resources that are being consumed, can I work out the payload of those individual jobs? One type is 4 times bigger than all of the other types. Therefore, I need to understand and forecast the occurrence of those big jobs and how many of those that are going to occur, and then start building in more of detail.
Eric, do you have anything on this?
Oh no, Jim's basically covered it. I mean, that's about as close as we can get to crystal ball. But again, it gets back to that issue of if we can understand what those job patterns are in those shifts, a good multivariate analysis environment will help to give us at least some clues as to how well we're matching. Are the jobs fitting the cluster capabilities? Those are, again, it's that doing a little homework and making sure that you're keeping on top of what those shifts and trends are in the job capabilities.
Wonderful. Thank you both. That's all the time we have for questions today. On behalf of today's presenters, I know we apologize for some of the audio quality, and we thank you for staying till the end. We will be having a replay of this webinar available shortly. Once again, thank you for attending today's webinar, and have a great day.